March 21, paper 2, variant 2. Question 1. Student has a measuring cylinder containing water and also a balance. Which of these could she use to find the volume of a small metal sphere? If she wants to find the volume, she needs the measuring cylinder and water. That's all she needs, right? The measuring cylinder and the water only. A ball hits a bat with a velocity of 30 meters per second. It leaves the ball with a velocity of 20 meters per second in the opposite direction. The ball is in contact with the bat for 0.1 seconds. What is the magnitude of the acceleration in contact? Can I find the acceleration? Yes, I can find the acceleration. V minus u over t, right? So the velocity, the final velocity was 20, right? This is the v, 20. Minus u was 30, but you cannot leave it as it is. You have to change the sign. Why? Because it's moving in the opposite direction. So this is actually negative 30. So 20 minus 30 over the time, which is 0.1, giving you a huge acceleration of 500 meters per second squared. Train begins a journey, travels 60 kilometers in 20 minutes. What is the average speed in meters per second? So this is actually 6,000 kilometers and a total time of 20 minutes times 60. 20 times 60. So this is 50 meters per second. Total distance over total time. I'm sorry, this is not 6,000, this is 60,000. 60,000. Yes, this would be 50. Which statement about the mass is correct? Which statement about the mass is correct? A mass of 10 kilograms weighs 1 newton near the Earth's surface. No, it would be 100 newtons. Mass is a gravitation force. No, that's weight. Mass increases when the no, again, this is weight. The greater the mass of the body, the more it resists change in its motion. Yes, it would be more difficult to push a mass, a huge mass, and it would be more difficult to stop it from moving. A small bottle has a mass of 20 grams when empty. The volume of the bottle is 10 centimeters cubed. When full of liquid, the total mass is 150 grams. What is the density? Density equals mass over volume. Mass density equals mass over volume. So the mass would be 150 and the volume, what is the volume? Okay, the volume is 10. The mass is not 150. The mass is 150 minus 20, right? 150 minus 20, which is 13 grams per centimeters cubed. An object of mass 0.8 kilograms is moving in a straight line at a velocity of 2 meters per second. Okay, a force is exerted on the object in the direction of the motion for a period of 1 minute, and the velocity increases to 6 meters per second. What is the force exerted on the object? You can say force equals mass times acceleration, or you can use the equation of the impulse force times time equals mv minus mu. For this question, we will not change the direction of the force, right? You will not change the direction of the velocity. Why? Because it's in the same direction of the motion. So the force times the time, what is the time? It is 1 minute. You need to change it to seconds. So force times 60 seconds would be equal to 0.8 times the final velocity, 6 minus 0.8 times the initial velocity, 2. Then you divide by 60. When you divide this by 60, this would give you a force, a very small force of 0.053 newtons. Yes, it's a very small force indeed. Which statement about the acceleration of the object when it is at point P is correct? Is there an acceleration? Yes, there is an acceleration. In which direction? In the direction of z, because it's in the same direction of the force, which is the centripetal force, right? Centripetal force. What is the moment of the force about point P? So we have force times perpendicular distance. Which distance is the perpendicular distance? S would be the perpendicular. So it's F times S because 90 degrees. A gas molecule strikes the wall of the container. What happens to the kinetic energy? What happens to the momentum? The speed is the same, right? The speed stays the same. So a lot of you might say, well, the momentum and the kinetic energy do not change. Actually, the kinetic energy does not change. Yes, kinetic energy stays the same, but the momentum changes. Why? Because it's a vector quantity. As you change the direction, the momentum will also change. Horizontal force pulls along a horizontal. I'm sorry. A horizontal force pulls a box along a horizontal surface. The box gains 30 joules of kinetic energy and 10 joules of thermal energy is produced by the friction between the box and the surface. How much work is done by the force? How much work is done by the force? You might say 20 joules, because if you subtract 30 minus 10, that would be 20, which is wrong. Why is it wrong? Because the force or the work done on the box would push the box, right? This work is the total input. If you think about it, this work done on the box is the total input. The total output, you'd have two different types of outputs: kinetic energy and thermal energy due to the friction. So what was the total input? The total input was 40 joules, because some of it was lost to the thermal energy and some of it was used by the kinetic energy. Okay. A crane is used to lift loads vertically. The output power of the crane is P. The crane lifts a lorry which has 3 times the weight of the car through 0.25 of the distance in 0.5 of the time. What is the output power of the crane now? What is the output power of the crane now? I hate solving these questions without numbers. And I always tell you, please try to solve these questions numerically. Please try to solve these questions with numerically. Okay. So you have the power of this crane is P. The crane lifts a lorry, which has 3 times the weight of the car. So let's assume a weight for the car. For example, the weight of the car is 100 newtons. A small car, for example. Small car, 100 newtons. Through 0.5 of the distance. What was the initial distance of the car? Let's say that the initial distance of the car was 10 meters, for example. And 0.5 of the time, what was the initial time? Let's say again that the time was 10 seconds. So I'm talking about the car for now. Okay, I'm talking about the car. The output power to lift the car is P. So P power is energy over time. You can say work done over time or force times distance over time. The force used was 100 newtons, right? Because this is the weight of the car. Distance is 10 and the time taken is 10. So the power used is 100 watts. Can I find the power? This is of the car. Can I find the power of the train? Sorry, of the lorry. Of the lorry? Yes, I can. Again, force times distance over time. The force of the lorry, it's 3 times the weight of the car. So 3 times 100, this is 300, right? This is the force of the lorry times the distance through 0.25 of the distance. What is 0.25 of 10? 0.25 of 10, right? 0.25 times 10, which is 2.5. And then over 0.5 of the time, 0.5 of the time, 0.5 times 10, which is 5 seconds. Can I calculate this? Yes, I can. 300 times 2.5 divided by 5. This will give you 150 watts. This is what? 150 watts. Which of these is equal to 150 watts? Which of these is equal to 150 watts? So let's see. 3 times 100 divided by 8. 300 divided by 8. No, it's not equal to 150. That is 0.375. This is wrong. A is wrong. 3 times 100. 300 divided by 2. This is 150. Yes, it is equal to 150 watts. C is wrong. D is 600 watts. This is wrong. C would be 800 divided by 3. I guess it's 233, which is 266, which is wrong. Okay, so this is the only correct answer. Question 12 is cancelled. Question 13, the box rests on a flat horizontal surface. On which face must the box rest in order to exert the least pressure? on which face? On X, to exert the least pressure. Air inside a sealed syringe is slowly compressed by moving the piston. The temperature stays the same. Which statement about the air is correct? The pressure of the air decreases? No, it increases because the molecules now hit the syringe more frequently or more quickly. Is it more quickly? No. Why? Because the temperature is the same. So it's more frequently because the area or the volume decreases. In an experiment, smoke particles are suspended. Brownian motion. Brownian motion. Air particles. Which of the following statement is correct? Air particles have large masses compared to the smoke particles? No. Air particles have high speeds. Okay, compared to smoke particles. And they move in one direction only? No, not one direction. Okay, in random directions. Brownian motion. The graph shows how the internal energy of 1 kilogram of a metal changes with temperature. What is the increase in the internal energy of the block of the same metal of mass 0.25 kilograms when its temperature rises from 40 degrees to 50 degrees? Of the same block of mass 0.25. So basically, can I find the temperature rise, the internal energy rise? Can I find the internal energy rise from of this 1 kilogram, and then divided by 4 to find the mass of the 0.25? Yes, you can do that. How can I do that? From 40 to 50. So this is 40. It was at, okay, 800 and, what is this? 812, right? This is 812. And then at 50, it should reach 815. So 815 minus 812, this is 3 kilojoules, right? Or 3,000 joules, right? This is 3,000 joules. This is the rise of the temperature of 1 kilogram of this metal from 40 to 50, rise in energy when you increase the temperature from 40 to 50. Now, if you want to increase the same temperature from 40 to 50 of not 1 kilogram, but of 0.25 kilograms of 1/4 the initial mass, then you will divide this amount of energy by 4, right? You will divide it by 4, and thus the total energy would be 750. Okay? Just think about it this way. 1 kilogram, it would take 3,000 joules. So 0.25 kilograms would take 750 joules. What is happening to the temperature of the melting ice and the boiling water? This is 0 degrees Celsius and this is 100 degrees Celsius. They are both constant as you have the ice. While it's still melting, the temperature will remain constant at 0 degrees and the boiling water will remain constant at 100 degrees. One end of copper is heated. What is the method? Okay, what is one method by which the thermal energy is transferred in the copper rod? In the copper rod, free moving electrons transferred from the cooler end, no, from the hotter end to the cooler end. Yes. Okay, the molecules do not move. Which change will cause the decrease in the rate of radiation emitted by an object? Decreasing the rate of emission, changing the surface area from white to black, this would increase it. From dull to shiny, yes, this will decrease it, yes. Approximate wavelength of air at the highest frequency. Air of the highest frequency. What is the highest frequency? 20,000 hertz. This is the highest frequency audible by a normal human ear. Can I find the approximate wavelength? Wavelength would be equal to the speed over the wavelength, over the frequency. Which speed should I choose? Whatever speed within the range. For example, you can say 330 meters per second. You can say 340 meters per second. Okay. Even if you say 300 meters per second, which is slightly less than the range, it would give you a number very close to the actual value. So if I say 340 divided by 20,000, this would give me 0.017, or the closest number is 0.02 meters. What causes the change in direction? When light travels from air to glass, the speed changes, right? The speed changes. All of these remain constant. Light is incident on a plane mirror. The angle of incidence is 38, then the angle of reflection will also be 38. Two rays with an angle of incidence 60 pass into dilute concentrated sugar water. 60, okay. Which row is correct? Refractive index and speed through the solution. Refractive index and speed through the solution. As the concentration increases, concentrated sugar solution, dilute sugar solution. As the concentration increases, what happens to the refractive index? What happens to speed? Can I think about the speed? It's much easier to think about the speed first, yes, because from 60 to 35 and from 60 to 40, so this speed decreases. Why? Because the angle decreases as well. So the speed through the concentration, okay, as the concentration increases, the speed will decrease. Why does the speed decrease? Because of the angle. The angle of refraction has decreased even more. What about the refractive index? Well, we know that the refractive index equals the speed of light in air over the speed of light in the medium. As you decrease the speed of light in the medium, then the refractive index increases, right? As you decrease the speed of light in the medium, the refractive index increases. Therefore, it should be C. A thin converging lens is used to produce a sharp image. Which statement is always correct? If you have a sharp image produced on a screen, the image is at the principal focus? No. Is bigger than the object? Is it always that the image is bigger than the object? No. Is the image closer? No. Image is always inverted? Yes. Which row gives the approximate speeds at which ultraviolet waves travel in air and in a vacuum? 3 times 10 to the power of 8 for both. X and Y. What are the parts of the sound wave labeled X and Y? X is a compression and Y is a rarefaction. Yes. The speed of sound in different states of matter. The speed of sound in liquid water is 1500. What about in ice and in steam? Ice is a solid, so it has to be greater. Steam is gas, so it has to be less. 3 methods of demagnetizing has been removed. Okay, you have 3 cores of different metals, P, Q, and R. At least one of the metals is non-magnetic. The cores are held above some iron nails. Which core metals are magnetic? Which core metals are magnetic? So when you had current in the coil, it didn't attract as well. So this is a non-magnet, right? This could be copper, for example, or something. This could be copper. It was attracting and then it did not attract. So this is iron, right? This is iron, which is a magnetic material. It was attracting and then when you open the circuit, it was still attracting. So this is steel, right? So Q and R, iron and steel. You have 2 metal spheres. You have a negative rod. What are the signs and the relative magnitudes of the charges induced on X and Y? Okay, charge on X and the charge on Y, the relative magnitudes. Well, I know this question might be a bit difficult. This question might seem to be kind of cancelled, okay, because the whole induction, okay, this induction spheres, they have been removed, but you are kind of required to know what would happen to a metal sphere if you bring a charged rod near to it. If this is a negatively charged rod, then it will repel the electrons to the other side. So the electrons, all of the electrons will move to this side, right? So the charge on Y would seem to be negative. The charge on Y would seem to be negative, and therefore the charge on X would seem to be positive. So we have a positive charge on X, you have a negative charge on Y, and they are equally magnitude. The magnitudes of them are both equal. Magnitudes of them are both equal. Okay. Now, question 31, which two changes to a metal wire will both decrease the resistance? What should I do to the length? I should decrease it. What should I do to the cross-section area? I should increase it. There is a current, which equation is the energy E equals VIT or IVT. Resistance R is connected in parallel with the 8 ohm resistor. The resistance of this combination is 4 ohms. Both of them together would give you 4 ohms. So R has to be 8 ohms. Why did I say 8 ohms without even calculating it? Because we should memorize it. If you have two equal resistors, then the total resistance of both resistors in parallel would be half the resistance, or half the resistance of each or any of these resistors. So 8 and 8 would give you automatically 4. You can use the product over sum equation, 8 times 8 over 8 plus 8, if you want to make sure. 8 times 8 over 8 plus 8, which would definitely give you 4 ohms. Okay, so this has to be an 8 ohm resistor. What happens to the brightness of the lamp and the potential difference across when the slider is moved from X to Y as the slider is moved downwards? The resistance decreases, the voltage decreases, and the brightness of the lamp also decreases, right? Why? Because the fraction or the percentage of the resistor covered is getting less and less. 35 is cancelled. 36 diagram shows an electromagnet. Switch is closed. The electromagnet magnetizes quickly. What happens to the reading on the voltmeter? What happens to the reading on the voltmeter? It keeps on increasing. No, it does not keep on increasing. It quickly increases. It stays at maximum. No, cannot do that. It actually quickly increases and then decreases to zero, back to zero. Yes. Why? Because this is a DC circuit, so it induces a current and then quickly reduces it back to zero. Yes. Which graph shows the voltage of an AC generator with peaks and zeros correctly? So A and B are wrong. C or D? Which of these are the peaks and which of these are the zeros? Peaks, okay, in C is correct. Are the zeros correct in C? Are the zeros correct? No, this is not a zero. This is actually a peak, but in the opposite direction. The zeros would be literally on the zero axis, okay, or on the x-axis. So it is D. It is D. Three students are describing the structure of an atom. Okay, what is the structure of an atom? All the positively charged are in the nucleus. Yes, positive electrons are electrons. No, negative electrons orbit. Yes, so 1 and 3 only. When alpha particles are incident on a thin metal foil, most of them pass through undeviated. What does this observation reveal about the nature of the atom? It is mostly empty space, right? It is mostly empty space. Okay. The average background radiation is 8 counts per second. What is the half-life of the source? Can I find the half-life of the source? Yes. So if we subtract 8 from each of these values, this would be 92. This would be 65. This would be 46, right? And if you subtract 8, this would be 37. I'm sorry, 33. Okay. And then 23. Half-life means that you have to divide the first number by 2, so 92 divided by 2, what is it? It's 46, which took 2 minutes, Again, you can use the minus divide, and then add, minus divide plus. You can use this by saying, well, 100 minus 8 is 92 divided by 2, 46 plus 8, it would be 54, so it is again 2 minutes.